This is section 1.8 and 1.9. This is our third lesson and final lesson for chapter 1. We're talking about combinations of functions, which means composing them, operations, and inverse functions. We're going to add, subtract, multiply, and divide. We're going to find compositions of functions, and we're going to use compositions and combinations. We're going to find inverses and talk about graphing inverses and the horizontal line task for inverse functions. First off, we're going to add and subtract. This is a lovely, first off, graphically, you pick out a few points and you perform the operation and see. Sometimes it's going to be telling you, the question that it's going to ask you, on your WebAssign is, it'll give you two functions and ask which one contributes the most magnitude, that kind of a thing. To figure that out, just graph them, and it makes it much easier to see what's going on. Algebraically, there's a wonderful website, Math is Fun, and this particular link will take you straight to their website, which explains it all algebraically. They do a really good job. So I'm not going to go into detail right here, but we will do a few. Okay, the composition of functions is when you put one function inside of another function. We can write the function in terms of y in function notation, which basically is f of something is equal to 3 something plus 4. Now we put whatever we like in the parentheses. To compose a function, we put one function inside the parentheses of another. We then calculate the inner expression and put the results into the outer expression. Okay, domains of a function. What we do is we take the domains of f, the domains of g, and then of the combined function, and we put them together to find the domain of the new function. So, what we have here is, if you notice, there we go. If you notice that f of g of x, this is written backwards, so I'm going to write it correctly. It's supposed to be f of g of x. Okay, this, on the other hand, is g of f of x. This is g of f of x. So I'm going to do both of them to show you what I'm talking about. F of g of x. Sorry, there's supposed to be an x. Didn't write that well. Okay, f of g of x is going to be f of 1 over x. F of 1 over x is the square root of 1 over x plus 2. Whereas g of f of x is g of the square root of x plus 2, which is 1 over the square root of x plus 2, because that's where the x is. Alright, you can see these are two very different functions. Okay. In this function right here, in this function right there, I can't have what's inside the square root be negative. I also cannot have the whole thing equal 0. So we're going to handle that each individually. So the square root of x plus 2, this has got to be greater than or equal to 0, which means x has to be greater than or equal to negative 2. Sorry, my x has this weird little bar on it. Sometimes if I don't lift my pen all the way, that happens. Okay, so now I have x is greater than or equal to negative 2. I also have that x plus 2 cannot equal 0, which means x cannot equal negative 2. When I put these two constraints together, I get that x has to be greater than negative 2. Because it has to be greater than or equal to, but it can't equal to. So that means I'm just left with the greater than negative 2. For this other function, switching to red, when I look at this function, the restraints on this is x can't be 0. But I also have that 1 over x plus 2 has to be greater than 0. So the constraints on the second function, first off, we know that x cannot equal 0, but we also know that 1 over x plus 2 has to be greater than or equal to 0. Okay, so I'm going to move the 2 over. I get 1 over x is greater than or equal to negative 2. I have to multiply both sides by x in order to get the x out of the denominator. So now I have 1 is greater than or equal to negative 2x. Divide both sides by negative 2. When I do that, I flip my sign. So x has to be greater than or equal to negative 1/2. Well, I also had that it couldn't equal 0. So I have a very weird domain for this particular one. If I were going to draw this on, sorry about that. If I was going to draw this on a number line, I would have 0, I would have negative 1/2. That's it. Okay, so I have to be, x has to be greater than or equal to negative 1/2. So I would have a filled in dot right here. I would go to an open circle on 1 and then also above. So I would have to turn this into two different interval notations. Alright, we're going to move on. Okay, this is the in-class practice. I'm going to kind of right now talk you through that. So I'm in the middle of pulling that up on my other computer. Worksheet. So you're doing 1 through 4. Come on. There it is. Alright, number 1. You should have this on your own. So you should be having this sitting beside you. You've printed it out. Or switch to this on your iPad and just listen to the voiceover of me. You have, find the following. F of x is 2x plus 1. G of x is 7x minus 2. First off, we add them. Then we subtract them. Then we multiply them. Then we divide them. So, I'm going to show you those. Adding them, that's easy. It's going to be 2x plus 7x. Sorry about that. 2x plus 7x is 9x. Plus 1 minus 2 gives me a negative 1. That was A. B is I subtract g of x. Well, the thing with when you have to subtract, you want to make sure you put this in parentheses so that you remember that the whole thing has to have that negative distributed. So I end up with 2x minus 7x, which gives me negative 5x, plus 1 minus a negative 2 is going to give me plus 2. So 1 plus 2 is 3. Alright, that was B. C, we multiply them. So we're going to have to FOIL these two, right? So we have 2x plus, for some reason I lost my thing, 2x plus 1 and 7x minus 2. I'm trying to write small. Alright, so I have 14x squared minus 4x plus 7x. So that's plus 3x minus 2. Alright, so that's the squared, so that's C. D, on the other hand, is divided, so we're going to have to care about the domain. So we can't simplify it at all, so it's just 2x plus 1 over 7x minus 2. That's D. But then it asks for the domain of D. Well, that means I cannot have that equal to 0. So I add 2, divide by 7. X cannot equal 7 halves. If I was going to do this in interval notation, negative infinity to 7 halves. Union with 7 halves to infinity. By the fact that these both have the interior are parentheses, not brackets, it means I'm never going to actually equal 7 halves. Alright, number 2. Evaluate the function f of g of negative 4. F times g of negative 4. So you can do it two ways. You can plug negative 4 into f, and you can plug negative 4 into g, and then multiply the outcomes. Or I can multiply the two functions, and then plug in negative 4. I like plugging the -4 in first. It's easier to deal with numbers. So I end up with 5 times -4 squared plus 1. That's f of x. Well, -4 squared is 16. Times 5 is 16 times 5 is 90. All right, 80. 80, sorry. Plus 1, that gives me 81. And then I have -4 minus 4, which gives me -8. So now when I multiply those two, I'm going to put them in my calculator. I have -8 times 81. And so my answer is, oh, sorry about that, -648. I have to hold my hand above the iPad. If I touch the iPad, I get weird things like that. All right, number 3. Use a graphing utility to graph f of g and f plus g. So put this into your calculator exactly that way. y1 is x squared minus 1/9. y2 is minus 3x squared minus 1. y4 is, since I'm adding them, x squared minus 1/9 plus -3x squared minus 1. Just put it all in one, okay? Then you're going to graph this. And what you're going to see is two parabolas, one pointing down, one pointing up. But the summation one, the f plus g, is pointing down as well. And if you look at it, the -3x squared contributes the most to the magnitude of the sum in both of those different areas. So the answer for both of these is g of x. All right, and then number 4, we're composing a function. So we want f of g and g of f. So first off, we have f of g of x, which is f of x to the 9, which is x to the 9 to the 2/3. Well, when I multiply 9 times 2/3, the 3's cross out and I'm left with 6. So my answer is x to the 6. If I do the g of f of x, in this case, it just so happens that those do end up the same. X to the 2/3 is equal to the 9. X to the 2/3. Well, again, I'm going to multiply 2/3 and 9, and I'm still going to come up with x to the 6. So they both have our x to the 6th. Now, we're going to look at the domains. Since it's in, okay, first off, we're going to look at the domain of f. F is x to the 2/3. Sorry? Well, that means it's a cube root, right? So this is the cube root, oops, sorry, of x squared. Well, I have no restraints on that. Even if it was with the greater than 0, because I'm squaring it, I'm making it a positive. Anyway, it doesn't really matter. Okay, x cubed, odd root, no restrictions. So this one is all real numbers. X to the, not 6, x to the 9th is all real numbers. Because, yes, it's odd, but it's to the power of, not a root. It's only the roots that we care about, even roots. But now when I look at the answer, I have an x to the 6th, again, all real. So my final answer is all real. Now, if I was going to put that in interval notation, it would look like that. All right, now we're going to move on. We are now on inverse functions. Find the inverse functions informally. Using a table or ordered pairs, one merely switches the input for the output. So to find the inverse, that becomes y, that becomes x. It's super easy. Graphically, it's basically the same thing. Pick out some points, flip them, draw the new one. It's a reflection over the x equals y line each time. Okay? All right. Now, to verify inverse, we compose them. If composing both ways, f of g of x and g of f of x, they both give you an x, you have they are inverses. And this is the one free response question we're going to have on the test. Is these two composed? Not these specific two, but verify inverse. Okay, so you're going to actually have to write that out. That's the only free response we're going to have. So we're going to do it right here. So first off, we need f of g of x. Well, that's f of x plus 2 over 3. Now, when we put that in place of the x and the f of x, that's 3 times x plus 2 over 3 minus 2. Well, when we multiply these, my 3's cross out. That leaves me with x plus 2 minus 2. Well, those add to 0, so now I just have x. So I'm going to do the other. G of, sorry about that, f of x, and that's equal to g of 3x minus 2. So now we have 3x minus 2 plus 2, right? Because that's my parenthesis over 3. Well, the minus 2 and the plus 2 add to 0, so now I have 3x over 3. The 3's cross out, and I'm left with x. So that verifies inverse. Both directions, and I got an x. That means it's inverse. Graphs of inverse, we've already talked about it a little bit. They give you, they are rotations, across that y equals x line. Now, we're going to use the horizontal line test to determine if these inverses have inverse functions. They all have inverses, but are the inverses functions? That's the question. So if you notice here, if we have a horizontal line test, this hits in 2 places. So once I rotate it, it would hit here. So yes, actually, no, the inverse is not a function. Sorry, I should say that. Inverse, not a function. Whereas this one, if I drew a bunch of horizontal lines across the original function, when I rotated it, it's still a function. Right? Because now that's all my vertical lines, Over here, same. Both of them are functions. Horizontal line test, that's what we're talking about. If you draw a horizontal line and can hit the function in more than one place, then the inverse is not a function. Okay, so we already said that one has no inverse function. This does not have an inverse function. You'll learn when we're doing trig and we have to do the inverse of this, in order to make it a function, we restrict the domain. So we just specify that it could only be between these 2 points because that'll give us a function. And this inverse is not a function. This one has inverses, not a function. This one has inverses, not a function. The rest of them, let's do those in blue. Oh, no, sorry. All of these, the inverses are functions. Okay, my horizontal lines are not very horizontal, but you get the idea. All their inverses are functions. Now, the others don't have inverses. They're just not functions. Moving on. Now, to algebraically find one, we do what's called SSA. I specifically put a tougher one here so that you can see how it works. To find the inverse, first thing we do is substitute y for f of x. So that's what I did right here, see? Substitute. All I did, change the f of x into a y. The second is switch x and y. So notice I switched the x and the y. Now the third step, the third S, is to solve for y. So I'm right here. So all of this is the solving for y. Alright, first thing, subtract the 3 and divide by the 2. That's what I did right here. Subtract 3, divide by 2. Now I've isolated the square root, so now I have to square both sides. Notice my 4 is 2 squared, and I have my top squared. Now it's going to equal y minus 1. I still haven't isolated the y, so I have to add the 1 to the other side. That's right here. Now, if I FOIL out the x minus 3, I turn the 1 into a 4 over 4 for a common denominator, I add it all together and I would get this equation over here. So this would be my inverse. Alright, so now you have the rest of your in-class practice. All I'm trying to do on this one is show you this is exactly what WebAssign is going to look like. Right? It wants you to first off find the inverse. So the inverse of the cube root of x is x cubed. Okay, that's your inverse. That's what f to the minus 1 means. Now to verify, you're just going to compose the two functions. You're going to put x plus 3 inside here, and you're going to put cube root of x inside there. So really, if you look at your paper, the two sets of parentheses in each column have the same thing. They have the first one, inverse of x, which was x cubed. You're going to have x cubed and x cubed. For the second one, what goes inside is f of x, which is cube root of x. So that's what goes in the two parentheses, cube root of x and cube root of x. And that's all there really is. So that one's really easy. Number 6, use the graph of the function to sketch the graph of its inverse. So what I do is I draw that x equal y line, and I try to sketch a rotation around it. And then I just translate it over to the second set of axes so it's all by itself. Alright, number 7, does the function have an inverse? Well, does it pass the horizontal line test? That's up to you. Alright, now you have homework to do. It's going to be 1.8 and 1.9. And then next class, we're going to have the study guide, and Thursday or Friday will be the test for Chapter 1.